In this video, I will be demonstrating the relative densities of gases. Specifically, I will be showing how carbon dioxide is relatively more dense than the air we breathe. For this demonstration, you will need a sturdy piece of glassware. If an aquarium is available, that would be ideal. You will also need vinegar. Vinegar from the store is perfect. Baking soda. Bubbles. And lastly, measurement utensils. So here's what I'm going to do. I'm going to fill this glass container about half full with carbon dioxide by reacting baking soda with vinegar. So here's the nitty-gritty of how I calculated how much baking soda and vinegar I needed to fill this container half full with carbon dioxide. To begin, I filled my glass container about half full with water. This also happened to be the 1 liter mark on my measuring utensil. Therefore, I knew that I had my glass container half full with about 1 liter. Therefore, I needed about 1 liter of carbon dioxide. Keep in mind that this is a rough estimate of the gas that I would need to fill up my glass container. This image shows the chemical reaction between baking soda and vinegar. The key from this image is the 1-to-1 molar ratio between the baking soda, vinegar, and the carbon dioxide produced. Next, we use the ideal gas law to convert the volume of carbon dioxide that we want to the moles that we want to produce. This allows us to stoichiometrically calculate how much baking soda we will need to react with our vinegar. We can do the same for the amount of vinegar that we need. Now I'm ready to react. As you can see, I have extra baking soda in my container as I'm going to use the vinegar as the limiting reagent. So now I can add the vinegar to the baking soda. And wait for the reaction to reach completion. Now watch as I blow bubbles onto the bowl. You may see some of the bubbles either bounce out really quickly or hover slightly above the bottom of the bowl. This is because the carbon dioxide produced by our reaction is slightly more dense than the air above. Here it is again in slow motion. I encourage you to try this at home, and I hope you enjoyed my video. Experiment, you will need a clear glass container, a more appropriately sized clear glass container,